Thank you very much. In this last 3D session, I'd like to talk to you how you can take your 3D content and tell a story with that 3D content. Been working in 3D for over 20 years now, and I always show this slide. Apologies for people who have already seen it, but I always like to put the question out there: why would you start working in 3D? It's not necessary to start working in 3D, but if you do, the audience, especially the non-technical people that you show it to, will get a better understanding of what you're trying to get across, which leads to better communication. And of course, there are certain 3D problems that can only be solved in the 3D space. But typically, when you show something in 3D, in comparison to a 2D map, the audience will get it quicker, will get it faster, and will be more engaged. There's a number of barriers to the adoption of 3D. One is I don't have any 3D content. In the previous session, I showed you, lots of tips and tricks how to create the 3D content or to get it from our data partners. And another one is that people want, and the previous speaker said it as well, people don't want it just on a desktop application. They want it in a browser and on a mobile device. So content, again, I spoke to this in the previous session. Esri has 3D content. Data partners have 3D content, and also we have solutions that allow you to create 3D content yourself. I would say as of the July release, we can now safely say that 3D is fully across the platform, across the ArcGIS platform available. We have it on desktop, we have it in a browser, and we have it on a mobile device. I hope to show you to that. If we don't run out of time, I'll show you on a mobile device. So 3D has matured significantly at Esri over the last 4 to 5 years, and it's right there now to be used and to tell great stories. So then we get to the group that I work for, which is solutions. You have this great platform, you have a bunch of data. What do you do with it? Well, we're building solutions on top of the platform for these 6 industries you see at the bottom that really try and solve a particular problem using 3D technology. These solutions, as it says here, are part of the platform. They're fully open source. They're fully supported and maintained, and are available at no cost. You can just download the code and the documentation of the Solutions for ArcGIS.com website. So the stuff that I'm about to show you is you just go to solutions.arcgis.com and you search for the particular solution, and you can find it. Now, one of the main use cases for 3D, and in all my time working in 3D, revolves around the proposed development in a city. You want to put a proposed development that comes from an architect, or maybe you've modeled it up in-house, but you want to see it in its wider extent in the city and see how it impacts the city. And that's why we developed these 5 workflows that we call together. It's called Review Proposed Development Solution. But in that solution are 5 workflows that allow you to place the development. You might get a model from an architect, and the solution will help you to put that into your 3D city model. And then there's a number of analytics and also a 3D public engagement piece that comes with it. So let's step through it using a story map. So what we see here is a Webscene of Queenstown. So a Webscene, for those of you that don't know it, is similar to a web map. It's just an item on ArcGIS Online that has a bunch of layers in there that you can view in 3D. And then the cool thing is that you can embed that Webscene inside of a story map, so you can really tell the story using text on the left-hand side and the 3D scene in the right-hand side. So here we have Queenstown. It's been modeled up by another solution that I explained in the previous session. So this one was used using LiDAR and building footprints to automatically extract the buildings. But then typically what a lot of our customers want to do is development review. So in the past, this is Queenstown. They were showing, just in 2D. In this location, there's a building going up, but nobody had a clue, what that would look like. So what you can do using that visualize proposed development workflow within the solution is bring that architect's model or the model that you created yourself and bring it into your city model and place it in the scene, allowing you to just have a look and see what that would look like from any angle and direction. And then there are, within the solution, a number of analytics that you can run. One has to do with visibility. the question you will get often is that the public will ask, from where can I see this new development? Can be also a monument or any other 3D object. In this case, it's the building. And what you see here, the analytics color-coded the building according to how visible that building is from that location. So the more red the buildings are, the more square meter of that proposed development is visible along the line of sight. So in this case, you can see it's about just under 200 square meters is visible from that location. So you can see, when it gets yellow, it's less visible, and anything that's white, you cannot see that building from that location. And it works the other way around as well. And this is being used in real estate use cases, is we can calculate from that new building what they can see. So how much of the lake is visible from the first floor or the second floor. So in this case, it's color-coded by lake visibility. So this solution really allows you to put a number on visibility and put a number on view quality, if you like. One example is in New York City. They're using this solution. There's a number of skyscrapers being planned around New York City. Central Park in New York City. And they're calculating for each of the condos how much of Central Park can be seen from the condo, because it drives in part the real estate price. If you get great view of Central Park, it's going to cost you more. So that's visibility. That's a part of the solution. Another one revolves around solar radiation. There are tools in ArcGIS Pro that do calculate solar radiation, but we just made them a lot user-friendly, that you can straight away calculate it for not only your topography, but also with the trees on top of the topography and the buildings. And another part allows you then to visualize the solar radiation on the top of the 3D building. And that straight away gives you a good idea, if you wanted to put solar panels on this particular building, where to put them. And we're going to enhance this solution so that you can even draw a polygon on top of the roof and then summarize all the radiation within that polygon, giving you a good indication if solar panels are a feasible option there or not. Then one analysis, this is quite important for Queenstown, and here in Australia as well, revolves around shadow impact analysis. So not just visualizing the shadow of a building, but doing calculations with the shadow. So in this case, here you see the shadow of the existing situation. Of course, we can have then the shadow with the building in there, but where it becomes really interesting is, what's the difference? What is the additional shadow caused by just this building there? So that area there in red is caused by the proposed development, right? Now, for one moment in time, that's not very interesting, but let's do a cumulative shadow analysis over the course of a whole day. We want to know for each area how much extra shadow is going to be there. And so the interesting map at the end is what we call a cumulative shadow difference map. So this is all the shadow being caused over the course of that day, just by adding that new building in that location. And a good example here is the city of Boston is using these tools to determine whether a new building built around the Boston Commons, which is the same as Central Park, but then smaller, if a new building will cast more than 1 hour shadow. That's the legislation. You cannot cause more than 1 hour extra shadow on the park, otherwise you will not get consent to build that building. So that is a number of 3D analytics. With what we call zoning envelopes, I'm building a solution at the moment that will allow you to visualize that regulatory volume that is described by your zoning regulations. So that is the maximum height on the parcel, the step backs and the setbacks. And this is again in Queenstown. We visualize their zoning volumes, which are these yellow transparent blocks, together with their as-built existing buildings, and straight away they could see where buildings were breaking, violating zoning, or where they had still room to grow, where there was only a small building, but actually the zoning code allows for bigger buildings. And then, of course, once you have placed your development in your 3D city and you run a number of analysis, you check the zoning regulations, then you want to engage with the public and get feedback. So we have a JavaScript application for that that allows you to, maybe we should load it directly. that allows you to ask structured questions from your audience using that 3D web scene that you already built. So here we have that same web scene, and you can see on the right-hand side the questions that you can ask. You can ask in total 32 questions. It's fully configurable. You can decide whatever questions you want to ask. And you can also decide what sort of answers you would want. Because then these answers are quantifiable, right? You can run some analysis on it later once you had enough survey responses. And you can tie them up to locations. So at the bottom, you see here a number of slides, which you can save within your web scene. And then I can say, I want answers for this location. So I don't like it here. I'm pretty negative and I disagree. And you can even put a free comment in. What then happens is we save this with a point feature service on your server or on ArcGIS Online. And that answer gets added to already existing survey answers. And you can see those colored labels. They indicate where people have made a comment. And also these labels have a color according to it was a positive answer or an in-between answer or a negative answer. So this kind of gives you a 3D sentiment map. You see in green is where people really liked it. And when it gets orange or red, people from that location really didn't like it. And if you want more information, you can simply click on the label and drill down and get the exact answers that people gave in this location. So here we have 35 responses, about equally divided. And for the next question, you can see it's about 50-50, right? And if you then really want to dig down even further, we can go to the actual responses themselves and step through them. So this really allows you to get a good feel of what the audience thinks about this new proposed development. So that is the public engagement piece. Then stuff that we are working on. So there's a number of solutions that will be released in December, and one revolves around development potential. And this kind of, I'll show you live, which is much more interesting. Let's go to that one. What we're doing here is we're calculating the gross floor area for an existing situation, and what I'll show you now is Miami-Dade County. And we're also calculating the as-of-right gross floor area. That basically that describes what can be built in that location. So here we have Miami. It's about 600, Miami County, I should say, Miami-Dade County. There's about 600,000 buildings that were created using that solution I showed in the previous session from LiDAR and building footprints. And there's an area going to be redeveloped here in downtown Miami. And these maroon colored buildings are the ones they're going to replace. And then using the solution, we can calculate what we call the plausible building that can be built on that parcel. So these are buildings that people can build if you don't change the zoning regulation. So you see it's a huge difference compared to the existing situation. And then you can go to certain locations and say, well, this is what is now, this is what is possible under current zoning regulation. Is that something you would want to see there? And it's color-coded by use as well. So I think purple is hotel, this is office, retail, and parking. So that is what is possible under current regulation. And then, of course, we want to know what is there now. So we have tools that can split up your buildings into the existing floors, calculate the floor space. And then, of course, we can go and start comparing the two different outcomes, right? Which leads to an indication of development potential on each individual parcel. So in this case, we calculated on that parcel we can build about 1,000 housing units or generate about 2,500 office jobs. So that is a solution we're currently working on and hopefully will release in December. This is slides showing the same stuff. Another one is what we call situational awareness. And it is kind of using that same model that we had before. Let's have a look at that one here. So this is actually Baltimore. It's about 200,000 buildings. But in this case, what you would want is show all your relevant information that you would need in a situational awareness scenario. So all your shelters, and other layers such as road closures, etc., you could show in a 3D model. You can also bring in sea level rise polygons and then show, for example, which buildings are going to be affected by that sea level rise. And so a very simple viewer, but very effective because it's a 3D view of the city. And then we're going to go one step further. So let's say, there's going to be an incident right here on this particular intersection, and we want to select all the buildings within a certain radius. And if you had interior information, such as floor level information, but even maybe spaces within floors, then you could say, there's about 45% of office space is going to be affected. And these are all the offices that are going to be affected. And if you want to look at just residential spaces within that selection of buildings, that is possible too. So, telling your story, bringing your story to life. So what I showed you is web scenes, right? Similar as a web map. You can embed those web scenes inside of the story map, making it a very effective way of telling a story. If you don't like the way our native web scene viewer looks, you can use the web app builder to build your own customized 3D viewer. No coding required. It's just simply grabbing a bunch of widgets and adding your own web scene, and there is your customized 3D viewer. You can go a step further and use our JavaScript API. Previous speaker also had they didn't show it, but it had full 3D capability. The Queensland globe is fully 3D, built on the JavaScript API. The 3D public survey application, same thing. If you want your own high-end 3D JavaScript API application, then the 4.4 JavaScript API is really good. And then another thing is all that 3D content can be embedded, if you want to, in kind of a Geo Hopper environment as well. And then just to show that we don't do only urban environments in 3D, we can go subsurface. So let's say here we're just looking top down, but we can go down below the surface, look at the different stratigraphic layers, look at the boreholes that come in. You can see they come in vertically and then go off horizontally. This is a fracking scenario. We can look at all the seismic, microseismic events in 3D. Just to show you that we're not restricted to just on top of the surface. We can go below the surface as well in 3D. Story maps, I think it's a really good way of bringing that story to life with the documentation on the left-hand side. For those of you that are interested, there is some cool particle effects as well. I don't think it adds much, but a lot of people really would like to have this kind of effect in 3D. Well, it is supported. These are trips of the Queen, I think, from London going to all the places she's been. If you have that use case, we have a solution. Not a problem. And as I said, 3D in the JavaScript, really powerful, enables you to build your own 3D applications if you want. And then we got 1 more minute left. So one other more example of 3D in the JavaScript API. This is an example of Manhattan, the skyscrapers. And this really highlights some new functionality that was released in July. It's the ability to query and filter 3D content in the scene. So if I just wanted to see all the buildings that were built in the last 17 years, I can just simply query them in 3D space. Or I can hook up and select the building here and then hook it up to the Flickr API and bring in photographs for that location. So you can build really rich applications this way. And then mobile, one of my favorites, simply because it's there now and it works. So I have to show you this. So on my Android phone, so it's available on iOS and Android and .NET. Let's see if we can make this happen. We can make it happen, but we have to do it that way. But you can see here now we got textured models. We have, I think, about 10,000 buildings, and it works really flawlessly and seamlessly on my mobile device. So you build your content once and then view it on a mobile device, in a browser, or on desktop. That was the roadmap. I didn't show you utilities in 3D space, but if you're interested in modeling your 3 waters underneath the city, then come and see me afterwards. And then finally, if there's anybody out there that really wants to get started in 3D and needs some help with getting the solutions up and running, or just wants to give some feedback, contact me. That's my email address. And if you want to have a look at story maps that we created, they are available at that URL there as well. And I'll leave it at that.
Thanks, Gert. So we have time for a couple of questions. Does anyone have a question?
So with the solar radiation scene there,
yeah,
you showed the amount of radiation sort of on the footprint.
Yep.
Does that take into account shading from adjacent buildings?
It does.
Yeah.
Yeah, the topography, adjacent buildings, and the trees. Yeah.
And you can use a specific date and time.
Pardon?
You can use a specific date and time.
Yes, you can. You can select by month or by day. It's all possible in the solution itself.
Yeah. Okay.
So we'll take one more question. Okay, if anyone has any questions later, you can meet Gert at the Tech Hub.